Yeah, Kevin Sproul here. I'm going to show you how to make a permanent magnet generator. Now this is going to be a really powerful generator, so be careful when you get it going I'm going to get it going. But this, I had to take this apart, this AC motor. See, had to take that apart, then pulled off the rotor with a puller. The puller, you see the shaft there has a little thing to put the tip of the puller in. So I did that, and then I put on my new little gauge there, some NASA technology there, a little duct tape. And I'm gonna hot glue the magnets. Here's my magnets. Now these are some powerful magnets. These are the kicker. Not them small ones, these are bigger. These are special ones. But I'm gonna weld them on there or glue them on there. 6 of them. Bing, 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 all the way around. Then I'm going to take this wire here. I'm going to wrap that around there about 500 times. Because what happens when you do this, it's going to want to shoot apart. The magnets are. So just having hot glue on there isn't. Like the first one of these I ever made, I used a shoelace. I got all the magnets on there, and then I used a shoelace. But you got to compensate for that distance, the thickness of the shoelace, you know. And you don't have a lot of room here. That's all I could fit was 6 magnets in there. That's all it'll fit. So the bigger ones of these, the better. I'm telling you that right now. The bigger that hole, the better. If you can find a motor with a big hole, that is great. That's what you want. But okay, so we're gonna do that. So I'll get back to you. This is what the magnets look like when they're on there. What you got is another magnet. You got 4 attracts. Right in a row, boom, 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 4, and then 4 repels. See that? You don't go north, south, north, south. You go north, 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 south, 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 south. So half the circle, half the cylinder here that this makes is north. Half is south. Get it? That's the way you want to do it. Now I'm going to wrap some I'm going to hot glue wrap some 24 gauge wire on here, around here. You have to notice something. To get the magnets to fit, I had to grind a couple of them. I don't know if you can see that. See, I had to grind down a couple of them. See that? Get them to fit. So that's okay though. So I'll give you another look in a minute when I get the wire on there. This is what it looks like after the wire's on there. I'm going to stick it in, see how many volts and amps we get. Pretty neat. Okay. I got the magnets in there, I got it all hooked up. There's my 150 watt DC electric motor. This is my homemade permanent magnet generator. Magneto generator. That's about the closest thing I can get to describe it. But it's just a half horsepower AC pump motor reverted into a magneto generator when I put the magnets in there like that and got her spinning. And it is lighting 7.2 watt DC diode light bulbs, or LED light bulbs. LEDs. Okay, and I'm lighting one over here. Okay, I'm lighting that one too. And I just run out of light bulbs. I could hook more up, but I just ran out of light bulbs. Okay. Here's so that's 57.6 watts or something. 57 watt, we'll say. Now I'm running these two batteries series together. There's my motor hookups, and I got a series together. I got all three of these series together, and I can run different speeds, see? But we only need that much power. So I got them series together. I got my lights all wired up. There's my diode bridge. It's not running itself. It's not a self-running thing yet. It's getting closer. So there's 56 watt. And here is my amp meter. DC amps. Zeroed out. And I'm doing 24 volt. Times 1.5 amps. 1.5. And I'll go to volts now. DC volts. I'll show you that. It's kind of hard one-handed. Put this one in here. Do this one-handed. So there's my hookup there. Here's my hookup going on here. And that gives me 23.82 times, that's what I'm pumping into that motor right there. 1.5 amps times 23.82, so 24. So 24 volts. Doesn't matter DC, AC, the wattage is the same. Roughly, by like 0.01 or something. It's a difference. So you got 57 watt. And I'm going to prove that that's 57 watt in a minute. Really try to, because this is a one hand. I need someone recording this video for me, seeing as it's the most important video of all time. But anyway, so we got 24 times 1.5 amps. 24 volts times 1.5 amps. That equals 36 watt. I got 8 7-watt light bulbs running. That's 56 watt. I beat it by 20 watt, 21 watt, and I still got power left, and it don't bog down when you shut these off either. Watch. It don't listen to the engine. See, I'm shutting off them lights. The engine don't bog down. You see? What I had to do there to get that to happen was after I figured out there's coils in here. And these wires, these 5 wires come out, and 4 of them are from the coils. Separate coils of wire. One's a low voltage coil, one's a high voltage coil. When you series them together, you get a voltage and an amperage. And when I go through, see, and then I come up here, I go off these wires here. See them plugged in there? Plugged in right here. I got wire here. Then I got a series. Then that wire comes over to here. I'm up to here into my 2-to-1 step down transformer, except I got it 1-to-2. I'm jacking the volts up into this one because, see, when you get the perpetual motion generator, you want this to be pumping about 30 volts at 5 amps down to 12 volts at 10 amps. So inside of here is only so big, so you can only get so many magnets in there. So I couldn't technically do what I was trying to do with this. I need a different one. You want to try a General Electric AC motor from like the 1960s is what you want. That's what I'm looking for. A shout out if anybody can, anti-gravguy1 at yahoo.com, if you can get me exactly what I just said, a General Electric AC pump motor from 1960s or whatever, 70s, anything. Try it all. They all work. They all will become a generator. We will figure this out, people. So right there I beat it. And then I got going from my 2-to-1 into a variac. So I jacked it up. I jacked my 100-watt up in my voltages and down in my amperages, and then got it into this, and I got it this on 105%. I can turn that down, up or down, and you see the lights barely get dimmer. If I go all the way off, see they shut off. I can get that baby all the way down to 80% before you can really even see a light difference. But I know in my measurements it's a 1 or 2 watt difference. But whatever, it's working. It just ain't running itself. Couldn't figure that one out yet. We will figure it out because I got the power. I'm pumping 36 into that electric motor, and out of my generator I'm getting 57 with more to spare. The only reason I can't show you more is because the only reason I can't show you more light bulbs is because see, these are all wired to my I guess you'll just have to take my word for it. I wouldn't lie to you. Remember that when I run for president or become a trillionaire. I would not lie to you, people. Aliens are real, I bet ya. Anyway. Okay. Let's see. Now we're gonna try to show you how I know them lights are. These are my wires to my lights. See all I got this series to 24 volts. It does matter what you hook up and what your volts are pumping out. So I might have to get back to you on this one. I don't know. This is going to be hard. Let's come over here. We'll hook you up. Negative. Oh, this won't be too bad. There's negative. So here's one light. Wait. Here's one light. .60. See that? 5.61. And here's all 4 lights. .22 excuse me. 22.93. Okay. I just turned it down, remember? My Variac. So let's turn it back up to where we had it. 105. This would be good. See, the lights didn't go up or down or nothing. Is that weird? It's pretty cool, actually. It's part of the whole discovery. 24.28 volts is what I'm pumping into these light bulbs at I can't use that amp tester. So we got this baby, amps, AC. So what did I say, 24.8, we'll say 24 volts. 24 volts I just did on the, here, let's get back. Let's get an exact read for all them. Okay. So there's a string of 2 strings. Okay, I got them seriesed. They're 6 volts each. I got them seriesed. 6, 6, 6, 6 to 24. And then I got paralleled another series. That's what you're looking at right here, believe it or not. So I got 2 strips of 6 volt lights, which I'll show you right now. One light is, oh yeah, that's, oh no, oh okay, yeah, one light is, we got my, see the voltmeter, 1 volt, one thing is 5.93, just arced them. Big mess. I'm gonna fix this up so you can really see it someday. arcing them out, hitting the diode with my light. 5.93. And that arc out should be proof to all of you that I'm not fucking around. These are all series together. What's this one say? 6.07. 5.93. So I mean, let's see, 18.26. That's 3 of them series together. Then 24.27. You see that? And then take my handy dandy. We go over to these amps here. I go to DC. Ooh. Oh, it was on DC. Sorry about that. That's DC. Zeroed out. Zeroed out. It's a 0. Put my negative in there. So I got these alligator clips. Ooh. Okay, I see what I'm doing. Okay, it's in there. See, that's how many amps I have total on this left or whatever completely out of my generator. So it'd be 24 at 6 amps. That's what it says I got left to go. We'll figure that out in a second. So that was a good read right there. And this is saying, oh, okay, right there. Oh, damn it. Shit, hold on. Had to get that other, too many things here, too many wires, and okay, I'm coming back. Okay, negative. No. Negative. I'm just trying to show you what one light bulb's amperage is. I already showed you what the volts were. 6. Amperage. See these two? Touching these two here. Oh. Damn. One. 1.1. 1.1 on the amp meter. With a bad connection there. So 1.1, one of these light bulbs gets, so we'll go over to the trusty computer. Trusty, rusty, dusty computer. Go to calculator. So, I set that baby at 6 volts. 6 volts on one light bulb times 1.1 equals 6.6 times 8 equals 52.8. You seen I'm only using 36, so minus 36. 16.8 watts of free energy. Totally free. All mine. For a lot of years, I'm messing around. So, we'll get it figured out. But I'm going to shut her down now. See you later.